Hello friends, today we are going to discuss angular motion and linear motion. So my name is Sunil and my qualification is BE Electronics and I have 10 years teaching experience and I am teaching the physics. Okay, so we are going to see the basic difference or very major difference between the linear motion and angular motion. So this is a demo lecture. So already I have written here and I will explain this concept one by one. Okay. So, what is linear motion? What is a linear motion? Any particle moving along the straight line path. Any particle moving along the straight line path, it is known as linear motion. Understand? For this, I will explain here. Suppose particle is at position A and after some time t, it goes to the position B. Understand? And this motion is called as linear motion. Particle is performing linear motion because it travels along the straight line path. So it is called as this motion is called as what? Linear displacement. In a in deeply we are saying what? It is a linear displacement, but this motion is what? Linear motion. In this linear motion, there are three types: linear displacement, linear velocity, and linear acceleration. And here in angular motion, there are three types: angular displacement, angular velocity, and angular acceleration. So I told you already what is a linear motion. Particle is moving along the straight line path. It is a linear motion. Or in deeply we are seeing what linear displacement. We are going to see further this. But what is angular motion? When particle performing circular motion or the particle moving along the circular path. And while moving it traces some angle. Understand? While performing circular motion, particle traces some angle and this motion is calculated with respect to angle. That's why we are called as it is a angular motion. Sorry. Understand? Particle while particle moving along the circular path, it traces some angle to the center. Am I right? See here example. When particle is at position A, after some time it goes to the position B dash. That time it traces the angle what? Here omega 1. Understand? This motion is what? Angular motion or in deeply or it is the first type what? Angular displacement because displacement is in terms of what? Theta angle. So it is what? Angular displacement because what? Displacement is in terms of angle. So it is called as angular displacement. Understand? So what is the unit of these two? Unit of linear displacement is what? SI unit of linear displacement is what? Meter. And SI unit of angular displacement is what? Radian. Because we have measured the angle in radian. Understand? So next point is what? Linear velocity. What is linear velocity? It is a ratio of linear displacement upon time. It is a ratio of linear displacement upon time. Yes. In particular time, how much distance covered by particles? It is what? Linear velocity. Its SI unit is what? Meter per second. And comparatively, see here, angular velocity. It is a ratio of angular displacement upon time. Here what? Linear displacement upon time. Here angular displacement upon time. Angular displacement we are calling what? Theta. Because while tracing the angle, suppose particle is position A. After some time it traces the angle what? Here we saying theta 1. I not right here. Sorry for that. First of all is trace the angle what? Theta 1. And after some time it traces angle theta 2. Understand? So actually what happened here? First of all trace the angle theta 1 after theta 2. Means here traces the angle, particular angles. So this particular angle traced upon time, it is what? Angular velocity. Means time taken to particle to cover some distance with respect to angle, cover some path with respect to angle in particular time. It is what? Angular velocity. Understand? and its a SI unit is what? Radian per second. SI unit of angular displacement is radian. SI unit of time is second. So it is what? Radian per second. Understand? Formula is theta by t. Understand? So next point is what? Linear acceleration. So what is linear acceleration? It is what? It is the ratio of change in velocity upon time. It is the ratio of change in velocity upon time. We are going to see here. Suppose particle is at position A with velocity v1. After some time with t, after some time t, it goes to the position B with velocity v2. So it is what? v2 is final velocity and v1 is initial velocity. So what is the definition? Change in velocity upon time. So final velocity minus initial velocity upon time means v2 minus v1 upon t. Understand? So SI unit of this what? Meter per second square. Why? Because change in velocity itself it is velocity, and SI unit of velocity is what? Meter per second, and upon second, meter per second per second. It is what? Meter per second square. Second goes downside. So meter per second square. Here comparatively, what? Angular acceleration. It is what? Change in angular velocity upon time. Suppose particle is moving with angular velocity omega 1 from A to B dash, and from B dash to B it is a omega 2. Understand? There is a change in velocity. Omega 2 minus omega 1 means final velocity minus initial velocity, or final angular velocity minus initial angular velocity upon time, given time. So it is what? Omega 2 minus omega 1 upon t. So SI unit of this what? Radian per second square. Same here, like linear velocity, linear acceleration. Omega 2 minus omega 1, omega 2 minus omega 1 upon t means what? It is a change in omega upon t, means change in angular velocity upon time, means meter radian per second upon second. Radian per second upon second. Second goes downside means radian per second square. So its SI unit is what? Radian per second square. Understand? So these are the basic and very very important things for JEE NEET, to understand the basic difference between the linear motion and angular motion. So this is our demo lecture. Okay, I hope you like this lecture. Thank you so much.